All right, Algebra 1A students, welcome to part 2 of lesson 5.5, where we're talking about equations of lines in standard form. In our last video, we talked about standard form as an easy way to find the x and y intercepts of a certain line, and then also graphing those x and y intercepts from the equation. Okay. The first thing we have to realize in this section is that when one of these numbers a or b is actually 0, then the equation ends up looking slightly different. Okay. For example, you could have an equation that looks like this: x equals 3, which is really saying 1x plus 0y is equal to 3. So it kind of is in standard form, but it's kind of not, because the 0y really isn't there. It really doesn't need to be there. So it's just x equals 3. Okay. When we have that, x equals 3, we're looking at a vertical line at all the x values where x is 3, because there is no y involved here at all. Y can be anything it wants. Okay. Just the x has to equal 3. So if we look at a graph of this, well, where's the point where x is equal to 3? X equals 3. Well, that would be right here. But the x value is also 3. The x value is also 3 right here, and 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 right here. And all of these points have an x value of 3, right? They all have an x value of 3. So the line x equals 3 is simply a straight vertical line right there on x equals 3, where the x value is 3. Okay? So x equals 3 is a vertical line. X equals any number is a vertical line. X equals 5 would be here. X equals negative 6 would be over here, and so on. X is always a vertical line. Okay? When we deal with the y variable, when we deal with an equation that looks like y equals, that's like saying 0x plus y is equal to 3. And again, this is kind of like the 0x doesn't really need to be there, and all we have is y equals 3. This line is the list of all the points where the y value is 3, starting obviously right here on the y-axis. But that's not the only point where the y value equals 3. And remember, in this case, there's nothing here about the x, so we don't have to worry about the x at all. We just get to deal with every single point where the y value is 3. Y is 3, y is 3, y is 3, y is 3, all in those places. Okay? So that leads us to a horizontal line at y equals 3, like that. Okay? Horizontal line at y equals 3. So x equals a number is a vertical line, and y equals a number is a horizontal line. So when you see those, don't get freaked out. They're actually the easiest types of lines to graph. You just go to the point where x is 3 and go straight up and down, or go to the point where y is 3, go straight left and right. You'll be fine. Okay? The other thing that's going to be in your practice problem set tomorrow is actually taking equations that are not right now in standard form and rewriting them to be in standard form. Okay? Because once we then have them in standard form, now they're very easy to solve. They're very easy to find the intercepts for and very easy to graph. So, in this case, I have an equation that is really quite complicated. It's actually in point-slope form. Y minus a y-coordinate equals slope times x minus an x-coordinate. So what I'm going to do is I'm going to basically rewrite this, simplify it, change it around so that it ends up being some number times x plus some number times y equals another number. Okay, that's the form I wanted in eventually. The first thing I realized in this equation, when it says y minus 2 equals negative 1/3 x plus 6, that I need to do is distribute to get rid of these parentheses, because in the form that I want, there are no parentheses. Right? There's no parentheses. So I'm going to distribute the negative 1/3 to both the x and the 6, and then rewrite my equation. So what it will now say is negative 1/3 times x plus negative 1/3 times 6 is like timesing by 6 over 1. It's going to be negative 6 over 3, and 6 over 3 is 2, so it's plus a negative 2. Okay? The other side still says y minus 2. Y minus 2. Okay? So now I'm going to try to move my numbers all to one side, all to the right-hand side, because all the numbers are over here in that c, that big c variable. Those are all my numbers. And then my x's and my y's are on the other side of the equal sign. So the first thing I'll do is try to get rid of this minus 2 and get it to go to the other side. So I'll add 2 on both sides. Add 2, add 2. What I end up with is y equals negative 1/3 x plus negative 2 plus 2 actually ends up being 0, so that's a 0 there. Okay, and now I'm almost there. I'm almost there. I need to now move these x's over to the left-hand side, get them over there. So in order to do that, I need to get rid of a minus 1/3 x, so I will add a 1/3 x on both sides. Add a 1/3 x. Now we know I can't add the 1/3 x with the y together, so I'm just going to end up with 1/3 x plus my y equals 0. And now this equation says a number times x plus a number times y equals 0. However, in order to truly write this in standard form, I am only allowed to use integers, which means no fractions. Okay? Integers means no fractions. No fractions. Integers, no fractions. So I have this 1/3 x right here, and in order to get rid of that, I'm going to multiply this entire equation, this entire thing here, by the denominator of my fraction. I'm going to times everything in there by 3, and what I end up with will be a proper equation in standard form. Okay? My whole goal in multiplying by 3 is to make this denominator get canceled out. Okay? Canceled with the 3. But what we have to realize is that multiplying the first piece by 3 means I also have to multiply not only the x part, but also the y part and the 0 by 3. I have to multiply all 3 pieces by 3. What I end up with is, in this case, just a 1x, because that's what was on the top of my fraction. The bottom goes away, I'm left with what was on the top. 1x plus, now I have to take the y and times it by 3, which gives me 3y, and then it equals 0 times 3, which nicely stays 0 for me. Okay? So this equation here, 1x plus 3y equals 0, is really the standard form of this crazy equation up above. Okay? So I just started to simplify as much as I could, first by getting rid of parentheses, then moving all my numbers to one side, all my variables to the other side, then timesing by the bottom of the fraction to get rid of that fraction and have standard form with just integers, no fractions. Okay? That's doing it from point-slope form. It's slightly easier to do it from slope-intercept form. So here I have an equation in slope-intercept form, which says y equals negative 3/7 x plus 5, and they want me to write this in standard form using only integers. So what I'm going to do here is first realize that the y doesn't have any numbers attached to it, right? All of my numbers without variables are already on the right-hand side of my equal sign, which is exactly what I want. So all I'm going to do is move the minus 3/7 x over to that left side. And to get rid of a minus 3/7 x, I'm going to add 3/7 x right over to this side, plus 3/7 x. Again, this side, that goes away. Not there anymore. So all that's left on the other side of my equal sign now is a 5. On the left side of my equal sign, I have 3/7 x. I usually write my x piece first, but it doesn't really matter. Plus a y. And that's all I had here before was just a y, so that's all I have now. 3/7 x plus y. Okay? So again, this now looks like standard form because it's a number times x plus a number times y equals 5, which is just a number. But the problem is I have this fraction here attached to my x. I really don't like that 7 being there on the bottom of that fraction. I'm going to try to get rid of that. The way I do that is by multiplying every single thing in this whole equation by 7. Okay? So this gets multiplied to here, and to there as well. What I end up with when I multiply that is 3/7 times 7 makes this bottom of the fraction go away, and I just have 3x plus, now y times 7 gives me 7y, and then on the other side of my equal sign I now have 5 times 7. 5 times 7 is 35. So I end up with this equation in standard form. Okay? So in this case, I don't have to do the extra step of moving some numbers around, doing the distributive property. It's much easier to do it in this case, okay, in this form. So I'd like you to try doing that now. I'd like you to try taking y equals 1/2 x plus 3 and rewrite that in standard form using only integers, no fractions. Move the x's to the other side and then times by the bottom of the fraction to get rid of it. Once you have it in standard form with only integers, come on back, play the video till the end, and I'll show you what we should have. What we end up with is this: negative 1x plus 2y is equal to 6. If you have questions about rewriting anything into standard form or graphing horizontal and vertical lines, please make a note to ask me in class tomorrow while you're working on your problems. Otherwise, that's all I have for you. Have a wonderful